Dr. Mahesh Gadekar. He has completed his Bachelor of Engineering from University of Pune and Masters of Technology and Doctoral from SVNIT Surat. He worked as a junior engineer for detailed project report, that is DPR, of other district road and village roads. Worked as project in charge for preparation of DPR of Krishna Koyna lift irrigation scheme, canal distribution, that is 5 km stretch. Worked as assistant professor in affiliated colleges of University of Pune since 2011. Currently, he is associated as assistant professor at Loknete Gopinath Ji Munde Institute of Engineering, Education and Research. Also incepted a startup named Geo Nashik in 2019. Apart from that, associated with NMC of rainwater harvesting and groundwater improvement project. Research publications, 5 essay articles with currently 1 citations, international contribution, reviewer of around 10 ACI indexed journals, and editorial board members of 2 peer reviewed international journals. Now, I request Mahesh sir to continue the session. Thank you.
Thank you, sir, for your introduction. A nice introduction.
Thank you, sir.
Okay. Let me share my PPT. Is it visible now? Is my PPT is visible? Okay.
Yes, sir. Yes, sir.
Okay. Okay. I thanks first of all Karodpati sir for giving me opportunity to speak for the challenges and opportunities in material testing in environmental and geotechnical engineering. It's a quite good topic. However, two different fields are combined together, environmental and geotechnical. And when we are talking about the material testing, two facts: environmental is a very broad aspect, and geotechnical being an broad aspect with reference to your civil engineering field also. There are quite good challenges we are having, and being an engineer, we are having good opportunities over here. Okay, so first of all, when we are talking about the materials in the engineering, what material is? It is the matter from which a thing can be made, or it is made up of, which is the dictionary meaning. And by natures, it is given as the material is defined as the substance, often a solid, but other condensed phases can also be included, that is intended to be used for a certain application. And in our cases, we are utilizing that for the building materials, and also whatever infrastructure we are having. It might be your roads, it might be STPs, WTPs, ETPs, or the buildings. All are associated with these materials, and even your soil over which our structures are resting. So it's a quite important topic to understand what materials are and how they are being analyzed. So this is what they need for justifying our material quality testing or material properties testing. So we are knowing that our buildings are getting observed with the cracks, or otherwise while actual construction of our buildings, We required a composite material that to be filled in such a way that it should be crack free from that. And while this is also engineering, Dalvi sir has explained that CMDs and all. So this composite material mixing is also one of the part while you are selecting right from the raw material to the composite material, and while its actual implementation, and each and every aspect is important in this selection. Further, if you go for the geotechnical exploration, we can see that a wrong study or the some misplaced study are giving us the issues such as the geotechnical issues arise because of it. This is one of the photo which is showing the honeycombing in the structure. So it is nothing but it's a engineering in which you should do a proper raw material testing and then it's designing. And that's why this material testing is important. However, this concrete part is covered by the Darvi sir. So I am discussing only the civil engine, geotechnical and the environmental. Okay, it's a bit of broad spectrum. Further, if I talk about the environmental engineering, environment is the surrounding, and thus whatever things we are seeing in nature which are closer to my proximity are this is a river picture taken by me on the Godavari river. As you can see, waterways over there, and what things are making it to the huge quantum are nothing but the materials which are coming to this river, right? Or otherwise, if I talk about the groundwater, then water is getting deteriorated because of this nutrients addition or also the heavy metals and contaminants addition. And another things that we need to see that is the variation in the groundwater level. Around 2 meter level drops have been observed in the groundwater uh, since last 5 years only. So that data is very huge. Not only the water scarcity along with the pollutant that we are facing, and thus material testing is important, or characterization of those things are important. Further, if you take it to the solid waste side, there is a huge quantum of waste is generated, and that need to be addressed so effectively such that this scenario will not be occur. And being an environmental engineering, the material testing is required. Now, generally we are utilizing a sample word over there, but material testing, whatever material we are having, we should know how to deal with that. And beforehand, I must characterize that samples or the materials so that I can implement a proper methodology to mitigate the issues caused because of this kind of problems, the materials. Okay. So coming again back to the exploration things. So whenever I am going for the geotechnical exploration or the any program exploration, the purpose should be identified, and it should be to determine the stratification and engineering properties of the soil underlying the site. The maximum amount of information must be obtained at the minimum cost, that is the prime requirement. It may be more economical to provide a conservative foundation design than to the expand large sums of elaborate exploration and testing program. On the other hand, sufficient exploration should be undertaken so that the geotechnical consultant is not in the position of making expensive recommendation to the project against the uncertainty that could have been detected by reasonable program. Okay, so these are the some pics from the geotechnical engineering and the concrete technology. So material testing. Why we should do the material testing is to able to select a material for given used based on the consideration of cost and performance to meet the norms as specified by the regulatory agencies, to understand the limits of materials and the change of their properties with the use, treatment of material before an application, to be able to create a new material that will have some desirable properties. And in this concern, material testing is important aspect. which are these opportunities? Okay, so since it is a broad spectrum, I am trying to control limit to the certain things. So if I could talk about the opportunities in testing, first important fact is that quality control. We must anyone who is going for under the project, he should control his quality of the materials and the quality of the process goods or each project. Then another opportunity we are finding, that is the testing methods or the methodologies, correction in the quantity of material and the project, and with this thorough understanding or the thorough understanding of the materials and their characterization, one may give the act as a consultant to be a provide a suggestions or options for the given materials or the suggestions that to be taken or to be followed beforehand using of that materials. So we are having huge scope into the testing of, for this geotechnical, and whatever major projects we are having. Over there, these geotechnical testings are important, such as your residential building, commercial building, or I may simply classify them into the any infrastructural project that involves a good costing sum of money. Over there, your sum of money along with the criterias of the loads. Over there, these testings are important, and over there we are finding opportunities for those testings. While for the environmental engineering section, the three aspects I am looking for. One is the sustainability, sustainable development goals, and over the sustainability, it is the human right to have a correct environmental aspect with this. And being an engineer, you must look for the public health and sanitation. Okay, these are the broader spectrum over where we are being an environmental engineer. We are having the possibility to work with the materials, and if I'm looking for the local market or the national market, then the opportunities in the field of water testing, water distribution, then decentralized water treatments, and over there I'm finding the opportunity. And similar way, air, wastewater quality assessment, wastewater effluent quality assessment, and intermediately designing a treatment unit. And one must have a very correct measurement of those qualities of the materials that are being there into the wastewater, solid waste, and furthermore noise is also one of the parameter that can be taken. And environmental is the field in which it's a very broad spectrum. So I think a small segment should be covered, which could be covering all the details. So with regards, I must say that it should be a sustainable one, your solutions and material checking, and correct testing of your material will only give you the sustainable solution. Unless and until it is not correct and not globally accepted, it should not be allowed. So again, slipping back to the geotechnical testing and sticking to the geotechnical part. So in geotechnical engineering, whatever construction site you are having, your sample are at the location in situ sample. So field testings are very important part, those which are not covered under the syllabus majorly. Then the soil sample procured, maybe disturbed sample or maybe the undisturbed sample procured to the taken back to the laboratory testing based on these soil properties. From the field testing as well as the laboratory testing, design office may go for the designing and analysis of the sample, and the final design details can be given to the site. So we are basically talking about the field testing. And environmental broad spectrum it is, I'm covering it later on. So coming geotechnical investigation program. So it is run in the following aspect. First of all, planning and of exploration program is one thing. Then geotechnical investigation to be done are identified and objectives are defined for specific test. Then extent up to which your investigation will be carried out will be determined, and based on that actual field testing is been done after deciding the location for the tests. Sample collected from the for the lab test and some case studies and its summary. A geotechnical investigation program should be such that it can be ascertained the foundation system is safe against which the shear failure, excessive settlement and the liquefaction. The planning of exploration program. The purpose of the exploration program is to determine the stratification and engineering properties of the soil underlying the site. The maximum amount of information can be obtained at minimum cost. It may be more economical to provide conservative foundation than to expend a large sum on the elaborative exploration and testing program. And on the other hand, sufficient exploration should be undertaken so that geotechnical consultant is not in position of making expensive recommendation to protect against the uncertainty that could have been detected by the reasonable program. Okay, so generally what happens in the exploration program, being a consultant, the issues faced are the availability of the amount, and since amount is varying or the lesser one provided to the engineers, so your testing locations and numbers have been reduced, and based on that you need to take a maximum factor of safety for giving you the solutions, and thus your costing for the project is ultimately increasing. So it should be ensured through the academics such that everyone should go into the testing field so that he will get a optimal cost for his project with a optimal designs. Geotechnical investigation can be carried out through this sequence: field recognition survey, field exploration, then laboratory investigation. From this result, a geotechnical interpretation and analysis are prepared, and finally report from the total exploration program. The objective of geotechnical investigations are to identify and describe pertinent surface condition, determine location and thickness of the soil and rock strata, determine the location of groundwater table, recover the sample from for the laboratory testing, conduct lab and field testing, and identifying special problems and the concern associated with the whole thing. It should consist of how many test bores should be required, or your plate load points are required. Depends whether type of project, and based on type of project we should decide which type of exploration should be carried out. And with the special request over here, SPT is boring is tried to be covered. A number of test boreholes have been determined. The depth up to which test bores are required have to be determined. Further, at which depth or up to after which condition your bores should be stopped, that condition have been decided. Actual field testing is carried out while the boring activity. The sample collected may be disturbed sample, undisturbed sample depending on the requirement. Laboratory tests are carried out, and correlation of field and laboratory test data for determination of the safe bearing capacity, settlement characteristics have been explored. So let's start with how things have been designed for material testing in situ. So Das has defined that there is no hard and fast rule exist for determining the number of boring or up to which depth boring are to be advanced. Okay. Still, the things vary on the soil variability, then the loads and the critical or the significant structure. Based on this, we should identify how many bores are required, how depth, is required, and up to which density means how closer bores are required, that will be defined. And still we are having the some references by which we can determine how many bores are required. So roads and multi-storied buildings have been defined by the solvers, and for the highway, the subsurface variability, if it is irregular, spacing of boring can be taken from 100 to 1000 feet. For the average subsurface variability, it is only 200 to 2000, and for uniform, it is 400 to 4000. And similarly, for multi-storied building, 25 to 75 for irregular, 50 to 150 feet for the average, and 100 to 300 for the uniform subsurface variability. So typically based on to the type of structure and the area available, we should design the locations. So for that some guidelines have been given in the IS code 1892 clause 2.3.1 for the compact building site covering an area of 0.4 hectare, one borehole or tile pit in each corner and one in the center should be adequate. For the smaller and less important buildings, even one borehole or trial pit. See here, trial pit is the another option available for the less important structure where load is supposed to be distributed within the required depth only. Trial pit is also sufficient at the center of the location. So area concern. Then number of test borehole. If soil is highly heterogeneous, some reference book are suggesting if you are having more than 3000 area, then at the edges of the corner edges of the building and the center of the plot, or otherwise you may go for the this triangular shape where by the soil exploration only you can determine the location. So generally it is to the corners and the edge center of the plot. However, majorly it is observed that people are not worried about the reports, but only the they are asking, sir, you just give me the SBC report and you should not investigate too much. Still, we are having, if it is highly for the ordinary building, to economize it and to save the time, two test bore holes can be taken. And if you are finding that your strata is varying within these two range, you may go for the additional borehole with the expertise you are having to the center. Generally, it is taken to the center of the plot. Okay, so additional borehole taking capability will be up to the expert available. So generally, if your variation is not large, then you can give your report from the two test boreholes only. When the area investigated is large and the plant layout is not finalized, the area may be divided into the grid of suitable size and the test point taken on the grid corner. This type of problem is taken into the dam case studies where you are giving a large sum of money for the infrastructure alone, and if that failure is occurring at that time, there will be loss of large sum of money, and over there this kind of grid fashion or radial fashion can be taken. For various tests, various structure, the number of test point may be considered as under the type of structure and the number of boreholes are taken. If you are having a lightweight utility structure, then minimum one test bore or the trial pit will be sufficient. Residential building or up to the 3-4 story apartment, minimum 2 test borehole and additional test bore as if it is a heterogeneous material. If you are finding in the two boreholes, then additional test bore may be taken. Multi-story apartment and the commercial building, 5 test boreholes are required. Industrial plants, Site can be divided under the grade pattern, and then it should be taken. Along with that, if your structure is resting onto the soil alone, then plate load testing also be taken. And further, your material should be tested into laboratory so that site field investigation result and laboratory test investigation can be matched or correlated. Then ESR, elevated service reservoir, minimum one test borehole can be taken. For the bridges, one test borehole should be taken for the abutment and pier location. Depth of the test boreholes. The depth of test boreholes should be extend up to the point at which vertical stress due to the proposed structure is equal to or less than 10% of original effective stress at the point before structure is constructed. And generally it is taken as the 1.5 times of the width of the footing below the foundation. So this is the suggested depth of boring. So for the poor subsurface condition, 6s raised to the 0.7, where s is the number of storage and d is the anticipated depth of the foundation. For the average 5 times, and the for good 3 times of the number of storage. So this is the anticipated depth for the test boring hole, and generally the depth can be stopped whenever your rock foundation is obtained, and below that say up to 2 meter people are going. So it depends on the variability, and your engineer in charge should decide where to the we should take a stop depending on the type of structure and the quality of material that have been found into the soil ground. So boring depth is governed by various factors by which we should take the decision. Foundation type, the foundation load, local experience is helpful. Look at the nearby structure if available. If no experience or other info is available, plan for the long first hole and then adjust accordingly. So these decision making arrangement are given up to the engineer in charge over there. How many boring and how deep? The final engineering can be no better than the data upon which it is based. So Sowers has already defined. So whatever data I am obtaining from the site itself should be taken into consideration for designing all these factors. So theory part is covered a bit. So there are various field tests available. So you can this PPT will be given to you. So SPT, TXPT, VST, CPMT. So there are number of tests available, and based on that methods, your result can be interpreted for your type of samples. Okay. So over here, I'm going to take a field test such as your SPTs. Field test. The most widely used method of the subsurface investigation is boring holes in the ground and simultaneously conducting standard penetration test and collecting the disturbed samples. However, sometimes due to the site constraint, time constraint, importance of the project, erratic subsurface strata, or to the supplement the data obtained from the test bores, additional field tests are required. So these are the summary of some of the field tests. Standard penetration test defined into the IS 2131. Application, it is the most common test, more relevant for the cohesion-less soil, less reliable for the cohesive soil and the gravel boundary strata. We are obtaining serious number of information such as relative density, angle of internal fraction. I will show you the data sheet for this. Then consistency for the unconfined compressive strength, set bearing capacity can be determined, liquefaction potential can be determined. In this, precautions should be taken. That weight of hammer should be 63.5 kg, height of fall should be 75 centimeter, and edge of cutting shoe should not be blunt or broken. Generally, what happened recently, I have come across the project in the Sapara for the bridge investigation, and the person who is doing that test he was not utilizing this weight of hammer. So your dynamic nature of the 63 kg, which is falling from the 75 centimeter, is not obtained, and you are getting a higher N value, and thus your safe bearing capacity is tremendously increased. So that factor must be taken into consideration, and the engineer in charge should take care of this fact of these standards arrangement that are made. Another thing observed or the challenge it is people are not doing complete 75 centimeter of fall. So that should be taken care while you are on the field. Then undisturbed sample, most common test, more relevant for the cohesive soil, N value when it is between the 4 to 30. It is difficult to obtain the undisturbed sample in the cohesionless soil, gravelly and boulderly strata. In this field density, moisture content, C5 parameter, SBC settlement, liquefaction potential can be obtained. For the undisturbed sample collection, you need to take a sampler which is the thin sampler, and for that formula is given how your sampler should be. Okay, and cutting edge should not be blunt and broken, which is in the same condition. Then another test is the vent shear test, which is for the soft cohesive soil where N value is lesser than the 4, and you can obtain the undrained shear strength where and calibration of equipment is must for the vent shear test. Okay, IS code which is defining it is the 4434, and I must say that we must follow only the IS code. Then the core pressure meter test, permeability test. Another thing that can be taken into the trial pit test. Over here, samples can be analyzed by the 2720. There are various parts are given, so undisturbed sample can be collected. Plate load test can be done, which is IS 1888. Then DCPT can be taken, dynamic test of cyclic plate load test. Then field CPR can be carried out. So these are the various tests that are being taken clear. In situ testing, when it is difficult to obtain undisturbed samples, cohesionless soils and sensitive test, in situ testing can be done by the SPT, CPT and the vent shear test. We are going to talk about the SPT right now. In this SPT, the tube sampler utilized are giving you the disturbed sampling IS 9640 and IS 2131 generally used. It is a thick wall split spoon sampler. It is driven into the soil at the bottom of the hole under the blows of 63.5 kg of hammer with the 750 mm of free fall, 75 cm of free fall. The number of blows required to driven 150 mm penetrations are recorded. The first 15 cm penetration is termed as the sitting value, and further the last 30 cm penetration are termed as the N value. So you are summing them and you are calling them as the SPT. Correction as per IS 2131, you should apply for the dilatancy. If the stratum consists of fine sand and the silt below the water table, the correction can be taken as the 15 plus 0.5 of N minus 15. And further with the figure, there is a reference figure is given, graph is given. From that, overburden correction should be applied. So this is the typical setup of the SPT. Over here, your bore is advanced up to the desired depth, and then with the casing, your arrangement should be such that it should be perfectly vertical, and the over this anvil, your weight of hammer is falling with the height of 76 centimeter. Okay, so it is mechanically or the automatic operation or the manual operations are also there. Then about split spoon sampler, the sampler is attached at the bottommost portion over where this N numbers are also recorded. So this is a typical sample photograph of the split phone sampler, which can also be seen into the video that I am going to show into the next slide. These are the sample collected from the split phone sampler, and these are the typical dimension for your samplers. Okay, let's see the video of that SPT. 1 minute. Is it visible to you?
No, sir.
1 minute. I guess I need to share it back. So now is it visible?
Yes, sir.
Yes,
Okay.
sir.
Actually, by mistake, my phone was taken vertically. So this video is can't be rotated. I have tried too many times. So over here, your anvil is there, and this SPT was carried out at a depth of 3 meters. Okay, in the Nashik city only. This is your 63 kg of hammer, and the people generally we are marking our 75 centimeter for the free fall, and then this 150 markings are generally done. So it is the same boring rigs are there, but at the end your split phone sampler is attached. So we are just seeing the operation of this. This person is see, so he has taken it to the required depth, and now he is removing the handle so that he can do the free fall. The arrangement made to keep it vertical, you can see they have a wire over there. So in this fashion, they are generally doing it the SPT, and your SPT sampler is driven into the soil so that it can collect the sample. And this test must be stopped if your N value, I mean blows are increased more than 50. Okay. 1 minute. Go back to the. Okay, this video is visible now. Okay, after SPT has been advanced, and we have recorded for each 15 centimeter how much blows are required. First 15 we are neglecting, and later on we are taking the measurements of them. So this is a split phone sampler which is from which he is taking the sample out. So it is the first cone which by which penetration is been there, and this is your split tube. So you can see actually it's sorry, I guess net was disturbed. Is it am I audible? Hello?
Yes, sir. Yes, sir.
Okay, okay. There is an interruption in internet actually.
Okay,
Okay.
sir.
So it's showing the cone, its tip should be sufficiently sharp. Okay, so this is what things have been advanced, and your sample is collected in disturbed form, as you can see the thickness of the blade. And now you can see that split phone sampler actually. So at this location, we found that there is a very clay mixture was there, and thus it is taking too much time. Whatever samples have been taken should be correctly classified and taken into the polythene bag so that we should not disturb the actual conditions of the sample, and it should be tested as early as possible. I'm stopping video. So in this fashion, your split pool sampler is there. I'm stopping the video right now. So I suppose standard penetration test and the SPT is very well understood, and I am going to show you the design sheet also, by which you can work out actually to determine the SBC directly by the SPT. Then types of sample collected. Two types of sample may be collected, that are the disturbed sample. These are obtained by the direct excavation, augers and the thick wall samplers. These are used for the mechanical analysis, water content determination, index properties determination, and the compaction test. Undisturbed sample can be collected to obtain by forcing a thin wall sampler, generally a shell pipe tube of 75 mm, 75 centimeter dia, into the soil at the bottom of the borehole by the hand or by jacking. In soft clay, silty soil below the water table, UDS is obtained by the piston sampler. In sandy soil below the water table, UDS is obtained by the compressed air sampler. These are used for the shear strength consolidation and permeability test. Okay, so UDS is not been covered over here. Then another test at the field we are taking, that is the plate load test specified by the Karodpati sir to take. However, I'm sorry for I'm not having video for that, but from photograph let me try to explain. So for plate load test, IS code 1888 1982 reaffirmed into 2016 is generally utilized. It is used to determine the field ultimate bearing capacity of the soil in place, which assumes that soil strata is reasonably uniform. Further, we can find the modulus of subgrade reaction with the help of this. However, plate load test having certain limitations, such as the test result reflect only the character of the soil located with the depth of the less than twice the width of bearing plate. Since the foundation are generally larger than this test place, the settlement and shear resistance will depend upon the properties of much thicker stratum. So these are the limitations with the plate load test. Another limitation, practical limitations could be this test can be taken up to the 3 meters only, and if you are going further, then there will be the accidental chances which are seen into the Dhule site for the tribal PWD. So if you are going more depth than 3 meter, then there will be chances of the accident because of this adjustables that you are using. So this is the setup of the plate load test. So we have seen that there are various methods to do the plate load test. However, the concept or the principle will remain same. One thing is that you should do the plate load test to see the bearing capacity of this soil. So your test plate should be there. So it could be your circular plate, or it could be your rectangular plate of size larger than 300 mm to 750 mm, depending on the type of structure. Okay, so we are using 300 centimeter of plates. Then loading jack is there. As you can see, loading jack in the both frames, and the adjustable. So this location is typically our only 1.5 meter depth, over where we have taken the poke line to the ground to the depth of 1.5 meter, and then adjustable are utilized to give the load. So I was talking about the principle for this. It is you need to give a top load which should be the reaction load, which should be greater than your soil bearing capacity. So generally we are adopting say 4 times more bigger one. So Pokeland generally it is 22 ton of poplane is there. So we are taking it as a load adjustment, and arrangement are made as shown in, over here. And then sequentially operations that you should take are the measurement of the settlement with the applied load for a certain duration until you are getting the constant deflection. I mean reduced deflection, say 1.01 mm per second. If that settlement is there, then you should go for the higher loads. Okay. So generally this test we have done for the buildings and the road pavements. You may go for the mechanical gauges or the proving room. So this is in this test was done in collaboration with the MERI, Maharashtra Engineering Research Institute, and these are the typical arrangement for our plate load test. I'm sorry, I'm not having video for that. And further laboratory testing is done, which are the most common methods which I already we have covered into the academics. So I'm just enlisting them: moisture content, unit weight, sieve analysis, Utterbuck's limit, compaction characteristics, hydraulic conductivity, consolidation, direct shear test, triaxial test, unconfined compression test. So these are the tests are conducted in the laboratories. So based on that data obtained from the field that can be analyzed further. Let me show you the design sheet that I have developed. So this is a okay. This is a geotechnical investigation report for the geotechnical investigation of, from the site, from the city center site in the Nashik. So typically your bore log should be made for the given characteristics. Your bore log is taken at the time of bore advancement, and recorded value of SPTs are recorded. The type of sample should be recorded, and in case your rock has been there, at that time what is the core recovery and the RQD for the given sample should be recorded. Okay, so core recovery is generally the how much cores you are recovered from the site, and while RQD is for the typically the ratio for the cores which are having size higher than 10 centimeter. So those only taken into consideration. I am having one of the core with me for you. 10 minutes. Okay, so generally these cores have been taken, and the relation I have showed you that SPT should be taken, and that SPT as per the IS 2131 you may go for the correction, and from 6403 you may calculate the set bearing capacity with reference to the field investigation details. So borehole number is given, depth of sample collection, then inclination of load to the vertical, typically it is 0 only. Then the value recorded from the field, which is the first two are first 15 centimeter have been already left, and remaining 30 centimeter you should sum up. So your SPT value obtained was the 14. So 14 value from the field is taken. Then how much overburden is there? So we need to give the factor. It is from the IS code. Typically it is 1 for our Maharashtra condition, and the overburden pressure can be calculated from the formula given in the in your 6403. Type of material which is taken from the borehole, that strata below the water table which is there, and correction are applied. Correction due to the overburden is taken, calculated, and the correction due to the dilatancy is applied, and your N value for the calculation of the SBC is been obtained. Angle of internal friction is obtained from the material testing. Specific gravity obtained from the material testing. Then your width of foundation, as per your requirement, your width of foundation and length of foundation have been taken. Shape of the base is chosen. Depth of water table. If it is, then correction will be there, which can be seen into the your calculation. Factor of safety is assumed. So this is the data given. Based on that, your calculation of the submerged density, then phi value is there, N5 value is calculated. Okay. So N5 value formula is given into your IS code. So you are need not have to worry about how you should progress the calculation. Okay. Surcharge intensity already calculated over here. For the report preparation it is given. Then from the tables, these are the tables which I have prepared specifically for the criteria. Okay. So from this table, you should calculate the bearing capacity factor, NQ, N gamma, SQ, S gamma, DQ, D gamma, IQ, I gamma, and then you should calculate the ultimate net bearing capacity for the sample, and then finally your SBC for the sample from the formula. So formula need not have to be explained; it is given into your IS code. And SBC can be calculated, and another your settlement characteristics can also be calculated based on to the given data, provided data which is observed from the field and the judgments. So it is a final settlement can be taken, and for depending on the type of the strata and on which it is resting, for the given settlement we are giving the SBC of that strata. Okay. Another one is the one minute. This is from the laboratory test. Bearing capacity by the shear criteria. It is again given in your 6403 IS code. So we are typically specifying the given data, required data for this. Failure mode is taken from the code, that which value should be adopted, which failure mode for that type of the soil, depending on to the our characteristics. Depth of foundation, existing ground level, groundwater table level, bulk density, submerged density, then moisture content, specific gravity of the soil, dry density. This can be calculated further based on the properties which have been specified. Then cohesion factor C and C dash should be given. Factor of safety assumption and internal fraction which is determined into laboratory. So based on the shear laboratory testing, we are going for the shear criteria. So based on the characteristics, these are the tables that are that I have framed for the typical values. Not typical, complete IS code I have tried to fill within the table so that I can utilize them for the calculation. So this calculation for the shape factor, SC, SQ and S gamma, DC, DQ and D gamma, and then inclination factor, generally it is vertical, so we are taking it as a 1. So it is typically only 1, so I have not utilized over here a calculation parameters. So depth factor and shape factor are calculated based on to the data available and the judgment of the IS code. So these are the formulas for calculation of those. Then corrections should be applied, effective surcharge should be calculated, and based on the type of the failure. So if you see over here, I have mentioned that which type of failure will be there. Okay, so I have checked for the R37, that is this E value, and based on to the E value, I have given the judgment. It is from the IS code only. So based on that E value, type of shear failure I have identified, and based on the type of factor, NC, NQ, and N gamma can be determined. Okay, so those values I have already determined for this and chosen based on to the type of failure. And finally, your formula is already suggested. Once you are having these values SC, SQ, S gamma, DQ, DC, DQ, D gamma, and the IC, IQ, and I gamma, and the NC, NQ, and N gamma, you can find out the ultimate bearing capacity, and thus the you may go for find the bearing capacity of that soil. Okay, so these are prepared by me only for the given IS code, and try to implement all type of condition. So it is okay. So this is about the geotechnical investigation that I have done so far, and plate load test reports have been not shown. Then calculation sheets have been shown. How much time we are having? So for this, I have not yet prepared the PPTs, but water, wastewater, and solid test are the important consideration with the environmental aspect, and being an material testing tester, you should adopt the standards, and the standard method specified are for the this environmental aspect are from the APHA manual, American Public Health Association standard manual, methods manual. From that only we should adopt the test, or otherwise you may find for the particular material or the particular raw sewage sludge or the solid waste, you may go for the IS code manual. So typically I am referring only the APHA manual. That let me show. Without PPT, let me tell you that what things you should concern about. So whenever you are on in the testing field, one must ensure that the accuracy of the test, the bias nature of the results, how much bias will be there and how you should interpret those bias. Then the calibration check, your method should be calibrated one along with your instruments. Okay. Then your results confidence interval, then their detection limit. Then one must ensure what are the limitations of the method specified. Okay, even though it is mentioned in the APHA manual, at in environmental currently, apart from the BOD, COD, that are well-known factors for the characterization of the water, wastewater sample, or even the solids. Apart from that, you may currently we are having the trace level of material that are of prime significance that should be studied, and they at that time from the manual whether your method is having that detection level or not. So method of detection should be specified. It should be within your confidence interval. Then the confidence over the result through the triplicates or the duplicates of the sample collected at the same time and the location. Then our precision, at what precise level we are taking the sample and analyzing the sample. Then quality assessment and the errors which are produced in the test. We must justify into our water, wastewater, and solid test. The major challenge that we are facing is the lack of availability of the well-versed personals into the field, because when we are talking about the water and wastewater or the solid waste samples, the collection, the location of collection of sample, its variation, it should be ensured. So your collection and along with that preservation of your sample, up to what time you should preserve the sample, in which container it should be preserved, that should be ensured, and up within how much duration you should test the sample, that must be ensured. Then there could be the, depending on the type of water, wastewater and solid waste, your sampling pattern should be designed, whether it should be pattern, or I may say methods. It is given as the methods, collection method. So it could be your graph sampling or the composite sample, and based on that your results variation are depending. And furthermore, the major thing is the safety concern in the environmental field. Safety concern in the environmental field. You are always saying that the person working into the water, wastewater or the solid waste fields, they are usually without the safety arrangement, and they are not knowing the possible toxicity or hazardous nature or the explosivity of the waste that they are handling. So all those things are should be ensured and are given in the APHA manual in the first section only. So we must adopt that standards in our laboratory condition. Okay. So over here, I'm just since there is a time limit, is the 5 o'clock. I have I'm stopping over here. It's over to you, sir. If any question is there, please. So generally, this is a famous quote from the Sir Francis Bacon. If a man will begin with the certainty, he shall end in the doubt. But if he will be content to begin with the doubts, he shall end in the certainty. So generally, typically being a material testing person and being in the academics, uh, we should be such certain, and we should give a suggestions or the consultancy to that level. The person should end into the certain decision only. We should be the economical again, and we should be within the cost limit of the cost limit along with the safety concerns. Okay, so thank you all for patience listening.
Dear participants, if you have doubt, you can ask directly by unmute yourself.
Hello. Hello.
Yes, sir.
Yes, sir.
Yes. I am Rajesh Kadare from D.Y. Patil School of Engineering. I want to ask you, have you come across a situation where you have been entrusted with the job of finding SBC of a made up ground? For example, why I'm asking this, because I was in government department actually long back. So there we come across situation where in very remote areas, we are expected to construct a reservoir. I'm talking about the elevated service reservoir. Maybe height, staging height is about say 12 meter, 15 meter like that. And the location or the land which is available with the Gram Panchayat is generally nearby. We want it rather in nearby area, and that should be a public land. So many times it situation comes like this, that some made up ground has been allotted to us. So in that case, have you come across this, and what bearing capacity have you suggested them? For example, average depth for which the villagers have dumped everything from rubbish to whatnot for say 5 to 7 years or so. The average depth in that area, which otherwise is a low-lying area, but now it has been made up to say 3 meter filling. So how would you be dealing that?
Sir, I have not come across such kind of situation, but the filling material I have come across where I have obtained the SBC of only 8. So in that case, we should ensure that sufficient test should be carried out, packing of the material, and further with the test result, we should go for the ground improvement.
So what solution did we give rather? Because in remote areas you don't have any equipments and agencies to provide you solutions. So in our department we have got standard designs for a different bearing capacity of soil. I mean, I'm talking about the foundation of the reservoir, isn't it? For a different staging height and different strata. So generally, the strata for whenever we meet with the BC soil is 5 ton per meter square. So even for a depth of say 3 meter, we don't add the air overburden into that. And we adopted 5 ton per meter square as bearing capacity and put the raft there and started our construction. So it worked out well, no problem till today. But I just wanted to know what bearing capacity do you, I mean, have you come across such a situation and you have given that bearing capacity to some agency? I mean, I am interested in finding the value. As you told, it is about say 8 ton per meter square you are given, isn't it?
So that was the filling material, and that is up to the 1.5 meter
Okay.
depth only. But if such condition arise, then with the lower SBC you are increasing the cost, and so we must ensure that which will be the cost effective method, whether ground improvement or the we should go deal with the same SBC consideration. That will be coming means solution. We should go with the all available solution and check for the costing. That will be the most suggested option for that.
Okay.
Sir, this is Dr. Samir Shastri here. Can you hear me? Yeah.
Yes, sir.
Yeah. I just want to know the in terms of cost, in terms of investment, what is the cost or investment required initially if we want to get our labs accredited? So can you put some light on that?
Sir, currently I'm in the startup process only. Till date, we have invested around 8 lakhs, and still it is two instruments have to be taken. So around for geotechnical lab, it took around 16 lakhs of budget for the initial investment apart from the accreditation process.
Okay.
Apart from the lab space too. Only the instruments I am talking about.
Participants, you can ask the question directly by unmute yourself.
Aniket sir, am I audible?
Yes, sir. Wait, sir, for 2 minutes. If you have any question, we will sorting that. Ask your doubts. Participant, if you have any doubts, you can ask.
Hello.
Yes, sir.
Sir, this is Vinod Vanwari from Mumbai. This soil testing and followed by consultancy is more experience, more results are more analyzed based on the situation and experience. Of course, supported by code. Which codes you recommend for this kind of testing?
Sir, being in India, codes referred should be the Indian standard code. And if our methods are not available, then we should go for the DIN code. If such method is not available, but IS code reference will be the enough for our situation.
Sorry, come again. Which code you said?
DIN code, European code, sir.
Okay. Thank you.
Okay, sir.
Any other questions? Ask directly. Dear participant, you can ask the questions.
Hello.
Yes, sir.
Am I audible?
Yes, sir.
My question is that suppose we go with the general things. So how much will be the cost involved for geotechnical say that particular consultation? How to go with the pricing and how much to expect the cost involved in geotechnical this particular consultations?
Sir, actually it is very I mean, if it is a specific one, then I could give you the answer. But if you talk about the only field testing, then we may expect from 20,000 above, our testings will be there. Depending on the type of structure, and this 20,000 will be based on the only trial pits suggestion. And if you are going for the plate loading testing and the further geotechnical exploration, that depends on the how much depth you are exploring, which type of test are required for the test. So if I have given around say 75,000 for the 3 boreholes depth for the factory. So it depends the situation.
Yes, sir.
Situation based.
It depends on the extent of exploration we are carrying out actually.
Yeah.
Yes, sir. Yeah, thank you.
Dear participants, you can ask the questions. I think no questions from the participants. We will hand over this session to the Kosti sir.
Thank you, sir. I, Ramakant Kosti, on behalf of Civil Engineering Department, Dr. D.Y. Patel School of Engineering, thanks Dr. Mahesh Gadekar, sir, for sharing his valuable time and knowledge for today's session. I also thanks our beloved chairman, Dr. Ajinkya D.Y. Patel, sir, Sri Hridesh Deshpande, sir, Director, Ajinkya D.Y. Patel Group, Dr. Sushant Patel, sir, Advisor, Ajinkya D.Y. Patel Group, Dr. Ashok Kasnale, sir, Principal, Dr. D.Y. Patel School of Engineering, Lieutenant Colonel Sanjay Korupati, sir, HOD, Civil Engineering Department, the speakers of the sessions, Mr. Sadananda Kode, sir, Mr. Jagdish Nandi, sir, Mr. Jitendra Dalvi, sir, Dr. Mahesh Gadekar, sir. I also thanks all teaching and non-teaching staff of Civil Engineering Department of Dr. D.Y. Patel School of Engineering. Special thanks to Mr. Aniket Nemade, sir, for his technical support. I also thanks all the attendees who make this FDB successful. Thanks a lot. Nemade, sir, any announcement from your side?
Yes, kindly fill the today's feedback form till 7 p.m. Everyone get the FDP certificate in 2 to 3 days. Thank you so much for attending this FDP. I'll hand over the session. I will say that this session is over. Thank you so much, Gadekar sir.
Thank you, sir.
Thank you, Mahesh. Thank you very much.
Thank you, sir.
It was a very nice session.
Thank you, organizers and all the speakers. Thank you so much.
Yeah.
Thank
So
you, sir.
great
Thank you,
going.
sir.
So great going. Bye.